let's continue. Right, so we can now create websites for a particular user. We can also retrieve websites for a particular user, right, if you give us the user ID. But as I mentioned earlier, we also wanted to maintain a reverse reference, right, where not only does the website know about its parent, but the parent knows about its children, right? So we can implement that from here as well. Right? So for instance, in the create website user, right? Not only can we create this relationship where the child is referencing its parent, we also want to be able to do it the other way around, right? That the parent knows about its children. Now, to do that, we would need to update the user model, right? Because the user model would have an array of references back to the websites, correct? So let's explore how to do that. Right? So one way that we could do it is to have in the user schema. Remember that we had declared websites the type. Wait, what's the schema here? Types, object ID. Notice that we had created an array that had references to all the child websites. Remember that? Right, but we never actually used it. Right, so let's use it for now, right? Notice that indeed we have all these websites, and 5, 6, and 7, right? Know that the parents are these, right? But the parents themselves don't know that they have these websites. Correct? Right. So let's play around with that a little bit. So to do this, we're going to need to update our model, right, and allow the model being able to add a new website to this user. Right. So to do that, let's look at the user model. In the user model, we'll need to add some additional information here, that a behavior that will allow us to add a website. Right, add website. Right, to the user model, and the implementation would be that you give me add website, right? You would tell me what the parent is. That would be the user ID, and you would tell me who the child website that you want to add. Right, so it would be the website ID, meaning we want to make a relationship between these two. Okay. So to do this, what we could do is find the user. Right? Once we have the user, we're going to update its array of websites. Yes, and then we're going to save it back into a database. Right? So first, let's find the user. We can say user model find by ID. Yes. We know the ID of the user. It's the user ID. Now we have the user. Now that we have the user, we can update the user. Right? So we can say then, and this is the user right here. So we're handling right here, right? The user that we're going to modify. So this is the user that is stored in the database that presumably has an empty array of websites, or it has in its array of websites several websites that is a parent of. Yes? So we're going to update to it. We're going to say, we're going to treat it just like any other object, right? It has an array of websites, and I think the name of it is right here. So there it is, websites. We're going to push into it the website ID. Okay? But once we push it, we have updated, we have modified this in RAM, right? In the database, doesn't know that we have modified this in memory, right? We need to go and save it back into a database, right? Tell the database that the object has been modified. So to do this, there is a save function. The save function will go back to the server and update that data model back in the database machine server, right? And this is what the promise is going to come back, right? So meaning, we're going to wait on this save to have completed, right? So this is on the user side, right? We're going to give it the user ID, the website ID, and this is going to add to the user object, okay? Now, when should this happen? But it should happen more or less at the same time that the website is being created, right? The relationship should happen. A brand new a website is created. It knows about its parent, and the parent knows about its children. Yes.
So when you decide to use save, when you decide not to?
When we want to go back and save it back in the database.
Save it back in the database.
Yes. Yep. We have an object that we just retrieved from the database. Okay. And we want to send it. Now we want to save it back into the database. We have modified, done something, changed a couple of things. It's almost like an update. Now, an update is an object that you're trying to update that you don't have a reference to, right? Meaning, fetch me a user, fetch me an object, right? Once you find it, here are the things I want you to modify, right? And I give you attributes that. Now, the thing is that I don't have those attributes to give you. Right? I don't have those. I would have to find it first, see what the original array is, right? Modify it, and then I could use it in an update. I could do that, right? This is a little more effective, right? I find it, I have the instance, and save would allow me to change everything I want, right? Using just plain old JavaScript as opposed to giving you an object of updated fields, right? I'm modifying it using just plain old JavaScript, and then I can use .save, right, to go and synchronize it with the database. Right? So it depends, right? If you already have an instance of the object, then you save, right? If you don't have an instance of an object and you still have to find it, you would use update. Okay. Okay. All right. So that's from the point of view of the user. But when should this happen? It should happen when we create the website, right? Here's the creator of the website. Here's where the website would be created. Once it's been created, we are guaranteed that this website has been added. Okay, notice that only after we create it do we know its ID, not before, right? We don't know its ID, so I couldn't call this before I actually create the website because I can't create the relationship. You see that? Here. The relationship is created by the website know who its parent is. Yes? But I can't create the relationship of the parent know about their children until it's actually created. Make sense? Right? So here is where now that I have the website, I can handle the function here, right? That's going to give me the actual document, right? The actual document that has been added to the server, to the database. See, up to this point, it's a website object that is being passed as an argument. Yes, right? That does not have any entity, hasn't been yet stored in the database. Yes, here I'm passing it and telling it, go ahead, insert it in the database. Right? Once that happens, then the promise is going to come back with the actual object, right? With the added underscore ID. And any other defaults, right? Any other defaults like created, date created, and things like that. Yes, right. So now I have the ID. I can now use the user model, which I don't have here. I don't have the user model, so I can load it. And that's the beauty of declaring each model in its own file, right? I can reuse it from anywhere, right? So from here, I can also load the user model, var user model, and just load it and require it. From let's see, let's go up one, user model. I have the user model, and I can now update the user model and say, hey, here's a new website that has been just being added. It's guaranteed to be in the database, and I have its ID. Right? I can say user model dot add website. To the user ID. I have the user ID right there. And I have the website that has just been created and has the underscore ID. See that? And this is what I want to return as a promise. Okay? All right, so let's try that. Let's log in as someone else. Yes?
Can we call website.save then?
I'm sorry?
Can we call save on the website we got?
We could, yes.
So
if we want to change something, but we don't need to change anything.
Not fine. We sent in the response to website instance we received in the then function. Am I right? So if we send this object to client, can someone in client?
Well, the thing is that the create website, I mean, yes, you might want to respond different things depending on what it is that you want the client to see. Our implementation doesn't really care about the response, right? Only cares about that it's 200, right? Because remember that right after we create it, we navigate away from the view, right? We go to a view that is anyway going to query for all the websites, so it's going to list them. But yes, depending on exactly what you need the client to see, you would decide what is that you want to return strategically, right? In this case, we don't really care what we're returning, right? What we do want to have is that we would want it to wait, right, until this has completed, right? We don't care about the data. We do care about waiting until the database has already done its thing, right? The website has been created. The user model now knows who these children are, right? So we should not navigate away until this has been successfully done. Okay. All right. So let's do that. Let's see the users that we have. We have show collections. And let's do a db.graduate user .find .pretty. Let's see who we have here. I have Poe and I have Andrew. Okay, and up to this point, I've been creating websites for Andrew, right, and none for Poe. So let's log in as Poe, right, and create websites for Poe, right. So if I log out, well, probably have to restart the server. Let's restart the server. If I go back and log out, I don't have a logout here. Let me just go to the top and log in as Poe. And I see my websites. Currently, my websites are empty. Okay, and indeed, we see that yes, the websites are empty here because I've never written code to update this anyway, right? But also from the previous query, we see that the user for the 3 websites that we had created all have Andrew as its parent. Okay, they all end with 78B1, which is, I believe, Andrew right here. Okay. All right. So let's add to Poe. So let's create a new website here, and we'll call this W123 create. So we come back and if we list Poe, notice that now Poe knows that it is the parent, the proud parent of website 123, right? It knows that it has that website. If we create a couple more, website 234. Notice that it has those 2 websites, right? So we could query, we could navigate 2 ways, right? We could have from the parent, we could navigate and see who the children are, or from the children, we could navigate to the parent. So we have a reverse, we have a 2-way reference, right, from the parent and children referencing each other, right? Almost like a doubly linked tree, right? It can be navigated in both ways. And same thing, the brand new website that we just created, right? We can say db. Let's see, do we have all the website here? Websites. These are the brand new website that we just created. These 2. Notice that they end up with 528 and 529, which actually match the 528 and 529 that we just created. Also, notice that the last 2 we just created, the parent, right? The parent in both cases is 4FE and 4FE, which happens to be 4FE Poe. So yeah, so they can both point to each other. Now the thing is that you would do both implementations. You would do one or the other, right? Depending on the use cases, right? Whether you want to be, maybe you want to be in your profile, right? You want to. I just logged in to my profile, and in my profile, for instance, I like to list down here the list of websites that I have. Yes, without having to navigate to the list of websites, right? And maybe I have a lot of things here, listing all the websites I've worked with, all the articles I've written, all the people I'm following, and all of them, right, are recorded as arrays of these objects, right? That I can then populate, right? Populate and retrieve all the fields that I need. Make sense? So again, depending on the use cases, you would go one way or another, right? The more common one and the one that makes more sense for folks that are coming from relational database is the foreign key implementation. It's the one that makes more sense for those that are familiar with MySQL. And same thing when we are removing, right? If we are removing a website, you need to update both, right? There's no such thing as a cascade delete, right? That if I remove from one, it will cascade remove everything that goes along. That's a relational database concept, right? That if I have a foreign key, the nice thing in relational databases is that I can tell the database that this key references this other one. If I remove the parent, I can cascade that remove to everyone who is referenced by those pointers, right? There's no such thing here, right? You would have to manually remove that, and that's where the challenge comes in, right? So if we implement a delete website, right, we would also have to, right, remove the website from the user, right? And let's play around with that.